Okay, so the point was like we completed so many things earlier, like this case and finding the ring and all these kind of things, like finding the electric field and electric potential due to ring, then this, and we talked about a lot about these cases, isn't it? Now, the point is what we are going to do today. We call it like we are entering into a very nice, or you can say, the most asked topic and the most interesting also, which we know by a name of electric flux and Gauss law. Is that clear? So this is the name of the topic which we give over here, and then we'll talk about that. Now, the question is, what is electric flux first of all, and why it is brought over here, and then the question is, what is Gauss law and why it is brought over here, isn't it? So let us define first electric flux, then we'll move ahead of that. Okay, ठीक है, एक मिनट, क्लोज सरफेस, हाँ, चलो, तो स्टार्ट करते हैं. So first thing is, the question is, what is this electric flux means? Now, अब ध्यान से समझते हैं, like try to understand. The point is, first of all, you need to understand about this word flux. ये flux क्या है? अच्छा एक बात बताओ. Let's suppose if I take any kind of a pipe, okay, this is my cylindrical pipe, and some water is coming out of it, like this one. Right or not? So see, that water depends upon this cross-sectional area of the body or not. Whatever is this cross-sectional area of the body, that much will be the water that will come outside, isn't it? This, this amount of object which emerges from inside to outside, we call it as flux. We call it as what? Anything can be a flux. Like here, if water is emerging out from inside to out, we will call it as water flux. If somewhere like let's suppose some electrons are coming out, we will call it as electron flux. Are you able to get me or not? So yeah, so flux means, yeah, not coming out. The point is like the amount of anything which comes out of a cross sectional area is called as flux. Are you able to get me or not? So here I am defining my electric flux. So what I will say, the electric flux is nothing but is the, or you can say, electric flux through any surface is defined as amount of amount of electric field lines amount of electric field lines emerging or passing through the surface. You can say the same, not emerging, you should say passing through the surface. Is that clear? So this is my electric flux is defined as that how much amount of our electric field lines are passing through any surface. We define that as electric flux. Are you able to get me on? Okay. Next point is, it is specifically denoted by a symbol which we call it as phi. This symbol has a name called as phi. Are you able to get me or not? So this is phi, which means electric flux. Okay. Now the question arises that how to find this flux. Like if I am talking about any cross sectional area and this much amount of anything is appearing out of it, so how to count that or how to measure that, or is it dependent on lines only, or is it dependent upon total cross section area only? So to understand about that in a much more greater sense, we need to define first thing, which we call it as the area vector. Earlier also I had a talk about that, the area vector. Okay. Now see, first thing is many people does not know, but area vector are of two types. Go ahead or not? Okay. So see, the first thing you need to talk about is our area vector. Are you able to get me or not? Now the question arises that, sir, what is the meaning of this? That if we are talking about area vector, then why we need to consider area vector? So first thing is, like let's suppose, ध्यान से देखो, let's suppose जैसे मैंने ये एक area draw किया है ना, so people think that area, since there are many points over here, then it is a scalar quantity, isn't it? But actually it is not an scalar quantity. Are you able to get me or not? Yeah, area is a vector quantity. What is area? Yeah. So this is the biggest misconception. People does not teach about vectors. When they are teaching vectors, they should make the students understand about this. That area is not a scalar quantity. It is which kind of a quantity? Vector quantity. Are you able to get me or not? See, so look over here. Then the question arises that if it is a vector quantity, then it will have a magnitude and direction, isn't it? So remember that the magnitude of area can be easily represented. Magnitude of area is simply whatever area you are getting. Like here, this whole surface area is my magnitude of area, or we call it as particular amount of area. Are you able to get me or not? But the question arises that if I am defining area as a vector, then it should have a direction, isn't it? Actually, you see that when we have a area is formed by the cross product of length and breadth. Remember that. So let's suppose if I have length along x-axis and breadth along y-axis, then if we take the cross product of that, that's the value of actually the area. Are you able to get me or not? And the point is, if I write anything as C vector is equal to A cross B, we know that C is that particular vector, or that particular vector which is present along the perpendicular directions of A and B or not. Or we can say that the direction of vector C is along the normal, isn't it? So basically the direction of area is always along the along the normal. Are you able to get me or not? So area is a vector quantity where if I want to define a vector, it will be written as magnitude of area into n cap. N cap represents unit normal vector. Are you able to get me or not? Is that clear? Now you can see that this n cap can be present along any of these points. Like let's suppose if I say over here, this is n cap, this is n cap, this is n cap. So any vector you see means always for any kind of area, these all are the directions of area. Are you able to get me or not? And one common property my particular n cap follows that it must be parallel for that particular if it is a planar sheet. Are you able to get me or not? And if it is spherical, then the particular area vector is present. Like let's suppose if I say this is my spherical vector over here. Go ahead or not? So if you if you want to draw the normal, what you'll have to do? You'll have to draw a tangent and then you'll have to draw the normal vector over there. Are you able to get me or not? Then the area will be along that particular direction. Is that clear? So always n cap, the normal vector of that area will represent my area direction. Is that clear? And that's how we make our area to be a vector quantity. Which kind of a quantity? quantity. Now the question arises that does it only stay like that way, or does it has any kind of like different bases? The answer is yes, it has a different basis. There are two kinds of area vector. You know, 90% of the students of class 12 actually gets are not able to do perfectly the Gauss law of because of this concept, because they do not know that specifically we have two kinds of area vector. One we call it as uh, open surface area, open surface area vector, and then we have closed surface area vector. Are you able to get me or not? Yeah. Now the question is like how to treat open surface. Basically, you can think of like an infinite seed, void or not. It's an example of open surface, isn't it? A closed cuboid is an example of a closed surface area, isn't it? So when we have these kind of surfaces, I have to consider different ways of area direction. Got it or not? So if I have open surface, then for the open surface, there is a way to consider the area vector. How to consider it? Consider, I'm writing, how to consider it? Just consider that one perpendicular direction consider that one perpendicular direction, got it or not, as open surface area vector, and stick to it for the whole problem. For the whole problem. Now see, actually, if you see the surface, see, for this surface, as I have drawn my normal upwards, I can also draw my normal downwards or not? Yes. So then you will, yeah. So you at that time you might say, sir, then do we have two directions of area? The answer is no. We have only one direction for a surface area. How? That look into this. When it is an open surface, then for a particular problem or a particular way, you have to just consider out of these two normal only one normal. How many normals I have to consider only? One normal. You didn't require to consider any kind of two normals over there. Are you able to get me or not? And that makes our question simplified, isn't it? If I consider upward normal, then I will stick to the upward normal for the whole problem. If I consider downward normal, then I'll stick to the downward normal for the whole problem. Never ever it is possible that I'll include both the normals in the same numerical. Are you able to get me or not? If we do that, I'll get the total value to be 0, which is not possible. Okay, is that clear or not? So, when you have open surface, always you have to take only one perpendicular direction of the open surface, not both of the directions, and either one of them, and then just you have to stick to it for the whole problem. Are you able to get me or not? Yeah. Second point, let's suppose if I have closed surface, void or not, then for closed surface, always you have to remember that for closed surface, always consider the outward normal, not the inside normal. Yeah, I'll show you. I'll show why I told like this. So let's suppose if I draw a cuboid. Okay, है ना? cube, cuboid, whatsoever. That's an example of a basically a closed surface, isn't it? Now look into this. Now see, for a cuboid, how many faces I have? 8 faces. Sorry, yeah, 6 faces basically. So I have 6 faces over here, isn't it? Now the question arises that, sir, for all these phases, are you going to consider everything? The answer is no, I'll not consider everything, Balaks. So, like, let's suppose if I consider one of these phases, okay, right or not? So, if you see on the face, then I can once again draw two normals or not? Yes, I can draw two normals. Now, if I draw two, yeah, one normal will be inside and another normal will be outside. Yes, outside the plane, isn't it? I can consider two kinds of normal. First, normal upward of the plane. Yes, uh, outward, and then I can even consider inside. So, what is the consideration for these kind of closed surfaces that you would have to ignore this inside normal? Are you able to get me or not? Always you have to consider which normal? Only the outward normal. Whenever you have the closed surfaces, you have to always consider only which kind of a normal? Other outward normal. That means for what? Yeah. So point is always consider for any kind of a closed surface the outward normal. Never ever consider the inside normal. So like I have even for this space the outward normal and inside normal. So I'll not include the inside normal, but I'll include the outside normal. Are you able to get me or not? So any kind of surface if I have means for any kind of a closed surface always take outward normal. That means in whole of our calculation, whenever we stick to the problem, we have to only consider one way of the normal. Basically, that is the truth or that is the thing which this difference of open surface and closed surface is telling to us. Are you able to get me or not? Is that clear? Okay, so let us just try one question on area vector, then I will move to particular concept of flux and all. Okay, so बोल रहा है see the question. It is saying that let's suppose if I have XYZ axes, okay, this is X, this is Y, and this is Z. And my area, I take a particular kind of area. So okay, okay, I have a particular kind of area over here, right or not? Like this way. Okay, so you can see that this area is like a door, isn't it? You can clearly see. And the point is that this area with the x-axis means that particular with the x-axis it makes some angle and that angle is given as theta. This theta is given to us that this theta is equal to how much? 37 degree means the particular plane makes an angle of 37 degree with the x-axis A, B, C, D, I name it. The coordinate D has given as 0, comma 5, comma 0. Are you able to get me or not? And coordinate B is given to us 4, comma 0, comma 3. The question is very very simple. Find the area vector. Find the area vector. ठीक है, find the area vector, and it is saying that this is a particular square. Okay, they are saying that this is a particular square, right or not, of length 5 meters. Yeah. Why I told you 4 comma 0 comma 3? Okay, no, wait. The coordinates. Okay, 1 minute. The coordinates are originally not mentioned. What it is saying? Find the area vector if ABCD is an square of length 5 meters. बताओ. Find the area vector if ABCD is a square of length 5 meters. जल्दी देखो. It's very easy. It's very common. You can do it within 2 minutes only. So look over here. First thing first, remember that area vector is given as, I'll tell you hint to how to do it. Area vector is nothing but, you always say me, it is AB vector cross product of length vector versus breadth vector, which is AB vector cross AD vector. Are you able to get me or not? And if you interchange it, see, if I interchange it, I'll get another thing. So for this, I'll have another normal. If I just interchange, like here it is length cross breadth. If I write breadth cross length, I'll have to include negative sign over there. Are you able to get me or not? Got it. So look over here. So AB, how to find AB? AD, I know that length of the particular square is 5 meters. So this length from here to here is 5 meters, and this length from here to here is 5 meters or not? Yes, both are 5. So look over here. So this will have coordinate 0 comma 5 comma 0. Theta is how much? 37 degree, isn't it? So look over here. If theta is 37, then I can construct a right angle triangle over here or not? Are you able to get me? I can construct a right angle triangle over here, isn't it? So now the particular, if it is 5 meters and this angle is 37, so this length will be what? This is hypotenuse, this will be base, and this will be perpendicular. Yes. So on the 4 meters, and this is going to be 3 meters because this is 5 and this is 37, isn't it? So therefore the coordinate of B is what? 4 meter along X. On Y axis it is 0 because this is lying, this triangle is in XZ plane. So 4 comma 0 comma 3. Are you able to get me on? So what is my AB vector? I got my coordinate. So AB vector is 4I cap plus 3J cap. Sorry, 3K cap. And what is my AD vector? So just take the area vector is 4I cap plus 3K cap cross 5J cap, isn't it? I cross J is K, so 20K cap plus 3K cross J is minus I, isn't it? So the answer is 20K cap minus 15 I cap. That's my area vector. Why done? So that's why I told you that area is a vector quantity, and there is a special way to consider. Consider for open surface only one perpendicular direction and stick to it. For closed surface, always consider the outward normal, never ever consider the inside one. Is that clear or not? ठीक है? चलो, so let's, with the help of this area vector, let us enter to our main task which we were discussing, and that is we want to discuss our electrostatic flux, isn't it? Yes. So electrostatic electric flux is denoted by phi, isn't it? So let us define. So I have electric flux, which is defined as phi. Now you think of one case. Let's suppose if I take this cylinder. Okay, I took this cylinder. Word or not? Cross-sectional pipe. Acha, you only tell me, if the water will come like this way, it will go out directly, isn't it? Now that's my normal convention, isn't it? Now what if, look over there, 1 minute. If try to understand that if this water hose or whatsoever is coming, okay, if it starts to come in which way? 1 minute. If it starts to come with a little bit slant height, it will come like if it is going to come like this way. So what you will see that the water coming out over here will be less or not. Now you think if in from this cross section the water is coming like this way, is it going to come out? Is the water will come out? If the water inside, is it going to come out? If the direction of water is like this way, so point is simple, very very simple, that we can observe one thing, one or two things, that sir, if I have any kind of area, then only the flux which is in the direction of open surface that will come up. And if I just if I just change the direction of these incoming quantities with respect to the particular cross section, then the amount can be reduced also and it can be made to zero also. ठीक. So, yeah, so the point is very, very simple. As we can see, that this is my cross sectional area, isn't it? Now, for the cross sectional area, for the open surface, I know that inside there is no such normal. So, the direction of the normal is outwards, isn't it? So, this is my area and the outward normal is given by n. Now, from this, let's suppose some kind of electric field is coming, or some, like let's suppose if I try to pass some electric field lines, got it or not? So you can see that these electric field lines are also a vector quantity or not? They are basically what thing? Vector quantities. So, and we can see that these vector quantities are making angle theta with this normal of the particular area vector. Are you able to get me or not? So the flux says you can only see that practically it is only possible to take out that kind of flux which is along the direction of normal or not, and all those amount of flux of fields which will be perpendicular to it will never come out, isn't it? So look over here, I can have the field two components, E sin theta and E cos theta. So practical reasons we can say that from any open surface only those things will come out along which the direction of area is present. Are you able to get me or not? And that's how, can I, सिंपल सी बात है, एक बात बता कि अगर मान लीजिए ओपन सरफेस है ना, तो इसमें से वही चीज बाहर आएगा जो इस पर्टिकुलर ओपन सरफेस के डायरेक्शन में होगा। कोई भी चीज इसके परपेंडिकुलर डायरेक्शन में होगी तो थोड़ी ना वापस आ पाएगी, इट विल नॉट कम आउट, इजंट इट? So the point is simple, that only things which are present, or only the flux which is present along the direction of area vector, because open surface means for the cross sectional area, our area vector is the only representation of direction, isn't it? Surface is not the direction. So anything which is present along the direction of area vector comes out, while anything which is present perpendicular to the area vector, it just gets cancelled out, it will never ever come out. Are you able to get me or not? That will not means, for the component E sin theta is of no use, because it will never ever come out of the particular surface area. It's just there, it's you can say it's just blocked out. अरे भाई तू ही सोच ना, मतलब अगर पानी आ रहा है, you have to think in the terms of water or not. Okay, so let us just make it very very clear in a much more greater sense. Or should I just leave it like this way? Okay, let us just leave it like this way. So electric flux basically, first thing is it is an scalar quantity, although my electric field and normal are my vector quantity. Are you able to get me or not? And if I have any kind of a surface, let's suppose if I take any kind of a surface, okay, okay, let me delete this. No use. Then, if I select any kind of a surface, now surface can be all like the point is very simple that surface will not be always planar. It can be of any shape, curvical also, any kind of shape can be possible, isn't it? So to find the amount of electric flux emerging out of it, the only process is first we need to define where is my area vector is going, isn't it? So let's suppose if I for a small region, like I took this small region, got it or not? Because if it is curvical, then normal will change here and there or not. So for this area, the normal vector is along this direction. Are you able to get me or not? And I call this area to be dA, a small area, isn't it? If the total surface area is A, then the amount of electric field lines which will come passing out of it, let's suppose these field lines are coming like this way, okay, and they make some angle theta out here. Let's suppose they are making some angle theta, then flux is defined as it is A, means a small flux will come, isn't it? From that a small area I'll have a small flux. So that small flux is defined as d phi and it will be given as 1 minute. E dot E vector dot ds vector. Are you able to get me or not? Or dA vector? Yeah. Are you able to get me? And if it is a dot product, then it can be written as what? E dot dA cos theta. Got it. So the point is very very simple. मतलब ध्यान से समझोगे ना तो प्रैक्टिकली हमें दिख रहा है कि सर किसी भी सरफेस में से, जैसे ये सरफेस है तो बेटा इसका नॉर्मल इस डायरेक्शन में है ना, एरिया का डायरेक्शन क्या है, ये है। और हमें पता है कि जो पानी आएगा वो इसी डायरेक्शन वाला पानी, दिस ओनली waters will come out, other waters if they are flowing like this way they will be blocked over here or not. Yeah. So anything like let's suppose if anything are passing like this way, which is making some angle theta with the direction of area, then what will happen? Only the component along the area direction will come out. So E cos theta will only come, isn't it? And E sin theta will be totally blocked. Is that clear or not? So that is why. What is flux? Flux was the count of total amount of electric field lines coming out of the surface area of. So that means it should be what? E into area, because amount of area into amount of electric field lines appearing over there. But they follow a rule that only the area direction will, means the only the quantities present along the direction of area will only come out. So that's why we need to take a dot product. Are you able to get me or not? So therefore, if I want to define the net flux through the whole surface area, so net flux is given as, it will be integral of total area, which is E dot dA vector, which is equal to integral E y dA cos theta. Are you able to get me or not? And this is how flux is defined. Are you able to get me? So let us define. 1 minute. Has happened. So here, what is dA vector? This is my area vector, and it is along the normal to the surface, and theta is my angle between the electric field, area vector, and electric field. Is that clear? Okay. Now, the question is, what if the electric field is uniform and the area is also uniform? Okay. So then, when electric field is uniform, means it's totally constant, then flux is nothing but EA cos theta. Void or not? Directly. No need of integral sign. Are you able to get me or not? Or which is equal to E vector dot A vector. Is that clear? So whenever you have a uniform electric field, then the question is very simplified. And implicit also, no need to have attention regarding that. Void or? Okay, so let us see. Let's suppose, let us take in some example. Let's suppose if I have some area. Now after talking this much on area, now you can get some ideas. Let's suppose this is my a particular plane surface area. So you know that this sign represents what? Vector going inside, isn't it? Or outside? Vector outside. Remember, it is vector outside the plane. Okay. And cross means vector go inside the plane. Take. So this is the sign convention. We use it in our whole physics. So here, if I want to draw area vector according to normal convention, it is a dot product, means area is coming outside. Are you able to get me or not? Now, the electric field lines are passing like this way. So can you tell me what will be my flux? Tell me, you don't have to use pen. Like suppose this is electric field E. So flux is E A cos. So what is my theta over here? Theta is 0. Electric field is in which axis? Along the x-axis. Dot means it is coming outside of the plane. So that means it is along z-axis or not. Normal vector is along z-axis or not. So that means what? EA cos 90. So flux is basically how much? 0. Are you able to get me or not? So that means whenever electric field line are parallel to surface, then my flux is always 0. ठीक है? अब ये parallel to the surface does not mean it is parallel to n vector. It does not mean that. First thing is you need to keep in your mind. Right or not? Parallel to surface means it's parallel to the plane, but normal will be perpendicular to the particular surface or not. So second side you can say I'll write it, or vice versa of electric field lines perpendicular to the direction of surface. So direction of surface and just the word surface has a two different meaning. Surface means this particular plane, and direction of surface means the normal vector which will be drawn on that plane. Are you able to get me or not? ठीक है? चलो, so tell me what will happen. What will be the flux? Let us do some questions. So let's suppose. Okay, I cannot take a save. So let's suppose if I have hemispherical ball like this way. Okay, 1 minute. Let me just decrease the save. I have a hemispherical ball. Got it? And you can draw any shape. I don't know. Got it or not? So this is my hemispherical ball, and some electric field lines are going inside it. And this hemispherical ball has a radius r. Then find the flux. Tell me what is the amount of flux passing through the hemispherical ball. ठीक है? Similar kind of hemispherical ball. Try to think. I'll take from Google. Uh, I need a vertical one. Yes, I can do this. Is there no such vertical one? Let me write vertical. Said there is no vertical hemispherical ball image. Okay, no problem. So I have this hemispherical ball. Try it. Try this. Try this question first. Then I'll move on. Okay, what is the flux? See, this is what is the confusion of students over here. People think that the area, they need to consider about the area of these kind of bowls or not. है ना? So whenever we are getting the bowls, first thing you need to keep in your mind, if you have a hemispherical bowl, the condition is very simple. You have to learn some of the flux things. That first thing you need to learn that for hemispherical bowl, I will only treat this particular region, means this circular region, to be our consideration of area. I'll not consider this spherical region as consideration of area, because for all of them the normal vector is going to be like this way, and when I take the electric field along this side they will almost cancel each other. Are you able to get me or not? So now the question arises that for this surface I need to consider the normal, and it is a what kind of hemispherical ball? Like hemispherical bowl is there, it's not a solid sphere. Okay, hollow hemispherical ball. So the normal will be along this direction or not? Okay. So the flux is simple E into area, which is pi r square. And then I'm considering normal along the same direction of electric field. So it is E into pi r square. I have to consider only one normal. I can consider either inside or either outside because it is a hollow body. So I'm just considering along the same direction to consider my flux to be positive. Are you able to get me or not? In the opposite direction also it's possible. What that answer will be? Minus E pi r square. What about those normals which are for the hemispherical ball in this horizontal direction? They will cancel this particular normal direction or not. So that's why we are considering along that direction. Are you able to get me? Okay. Similarly, like let's suppose if I take the electric field like this way. Okay. And radius of the ball is r. So now look over here once again with respect to horizontal. These electric field lines are making some angle theta, isn't it? With the direction of normal vector. So once again, here the flux will be given by formula. Pi will be equal to pi r square into cos theta because sin theta terms will be once again cancelled. Got it? So you have to always keep in your mind that whenever I'm defining the flux here, I have to always take the electric field line along the direction of normal and its component along the normal. So flux is defined as amount of electric field line component along the direction of area. Are you able to get me or not? Okay. So let's suppose. So you can write this definition that flux or electric flux you can say in common terms is defined as amount of uh, electric field lines or component along the direction of area. Is that clear? ठीक है? So we got to know so much things about our area vector and flux. Now let us implement it through some numericals. Okay? चलो तो बोल रहा है कि find the flux. क्वेश्चन दे रहा हूँ. Find the flux through given rectangular surface area which has sides A and B. Okay, due to electric field given as 8I cap plus 6J cap. And the area is drawn like this way. Okay. So you have XYZ axes and area is present along is present in this YZ plane. Got it or not? ठीक. This length is A, and this length is B. So length till over here are given. जल्दी से बताओ क्या होगा आंसर. Tell me. Tell me fast. This is the first case. Try to do the same thing for the second case. You do the first case. I'm drawing till that the second case. Tell me. You have two surfaces drawn like this way. Tell me what is the flux through both of the given surfaces. You do it. 2 minutes. I'm break. I'm taking. Okay. जल्दी बताओ. जल्दी आंसर दो. Hmm? 10. 10 AB. How come? Acha, in which plane this area is? YZ plane. So, if it is in YZ plane, the normal is in which direction? The normal is simply along n cap direction, means x axis, and you try to take always normal along the positive side, isn't it? So area vector is nothing but my AB n cap, and it is an open surface, so I'll consider only one direction of normal, isn't it? So in AB n cap means AB I cap. So when I take the flux E vector dot A vector, so ST, I'll really kill you. You are not able to solve even single thing perfectly. 8 I cap plus 6 A cap dot AB I cap. So what is your answer? 8 AB. Are you able to get me or not? Is that clear? ठीक है? Now the point is simple. This is my flux over here. Now you can also decide the what will be the SI unit of flux. Flux is written as E dot area, isn't it? Now E is written as Newton per Coulomb meter square. So what will be the flux? SI unit Newton per Coulomb meter. Are you able to get me or not? Similarly over here, how to solve this? Now the question arises, when I have angular areas, that's a big question to understand now. So you can see that these angular areas are nothing but a combination of two different areas. ठीक है? In a simple term, just treat it like a combination of two different areas. One, see, for this area, one particular image will be along this xy plane or not. So one image in xy plane. Means I'm trying to take the component of area. Got it or not? and one along YZ plane. अरे वाह, तुम खुद सोचो, जैसे मान लो अगर तुम्हारे पास कुछ इस तरह का वेक्टर होता है तो इसका कितने, एक एक्स के एक्सिस की तरफ कंपोनेंट, एक वाई एक्सिस की तरफ कंपोनेंट होता है ना. So similarly, area can also be placed like one along this way, one along this way. Then only it will rotate like this way or not. So see that this is my x-axis, this is my y-axis, and this is my z. This is x, y, z. If this angle is theta, so area along this will have a cos component, and area perpendicular to it will have a sine component, isn't it? तो इसकी टोटल एरिया क्या है, ए बी. तो इसमें क्या होगा, ए बी in xy plane it will be ab cos theta and ab sin theta. Are you able to get me? Now look over here, electric field. So look over here, for this ab cos theta means this will have a component along plus z direction, isn't it? So this will be written as this area vector means the, I call it as parallel, and this as perpendicular area component. Got it or not? So look over here. So area vector is given in two way. Got it or not? One is parallel, which is AB cos theta, and its normal is along plus z axis, isn't it? Because it is lying in xy plane. So AB cos theta k cap, and this is lying in so normal is along k cap now, and then for this it is uh, I cap. So this is my amount of area, and this is the direction of normal, positive normal, which we usually consider. So the flux will be simple. E vector dot A vector. Now k cap, if I take I cap dot k cap, it is 0, j cap dot k cap, it is 0. So flux is simply AB sin theta into 8 Newton Coulomb meter square. That's your flux. Got it? To the next question. बोल रहा है find the flux अरे समझ में आ रहा है ना? Are you able to get me or not? Totally. You have to always think about the area as a vector quantity and take its component, then write in terms of normal vector. And if you can write in terms of normal vector, you can directly find out the flux in a very easy way. Like here, area vector can be written as AB cos theta k cap, because for this the normal is along positive z axis, isn't it? For this the normal is along plus x axis, so that's why I can write it like that. Okay, so question is find the flux through the given rectangular surface due to given electric fields. ठीक. So look over here. I have x, y, z. This is B. This is A. Now the electric fields are given to you. The first electric field is 2x plus 7 I cap. Second electric field 6yz cap. Third electric field 6y I cap. Fourth electric field 3 x square plus 2 y pi. So I have got such kind of electric fields. We are passing one by one electric field, then I switch it off, then passed another electric field, then switch it off. Then for all of these electric field, I'll get different flux or not. Find the flux for all those electric fields. Do it. So you see, are these uniform electric field or non-uniform? Uniform or non-uniform? Hmm. So non-uniform means variable only. You have to say like that. Okay. Hmm. Do it fast. Tell me what will be the answer? What will be the answer? Okay. Now that's where Anurag sir comes. It's wrong. Perfectly incorrect. But it was a nice try. That's how I motivate the students. And that's how I put the depression in the students. Word or not. Okay? You will be like, sir, what the hell you are doing, huh? देख इधर देख ये किस तरह का है वेरिएबल है ना तो नॉन यूनिफॉर्म को हमने क्या बोला था नॉन यूनिफॉर्म का निकालने के लिए क्या फॉलो करना है इंटीग्रेशन फॉलो करना है ना इन केस ऑफ यूनिफॉर्म fields only I have to take e dot a now. So now see that I need to find a particular electric field. Now, if you look into the particular area vector, then area vector will be written as what? What is area vector? AB I cap, isn't it? Now, now you have to think that where this particular area is present. What's the coordinate of this area? Look into that area. It is at 0 comma 0 comma, isn't it? So now when I write for first case, okay, your answer of first case, when electric field is this, so flux is what? E vector dot d a vector, but area is uniform, so a vector. So what that will be? 2x plus 7 I cap dot ab I cap. So that is 2x plus 7 ab, isn't it? But that flux is present at x is equal to 0 or not? It is present for area at x is equal to. So flux I will define it for x is equal to 0. So what is that? 7 Newton meter square per coulomb. Right or not? 7 AB, sorry. Similarly, second one, second one, E vector is given 6y. So flux, so 6y means, then what it will be? Simple 6y into AB I cap dot j, but that is 0 or not? I dot j is 0. So flux is 0. And you can see even the electric field line EY j cap means what? Parallel to the surface. So that means it will be 0. Take. Next one is 6y I cap. Now that's an interesting case. Okay. Third one is E vector is equal to 6y I cap. Means the variable is varying. Y is varying. See, E vector, that means what? See, that electric, what? Acha, can you tell me what is the meaning of this 6y I cap? See, try to understand. Let's suppose if I have xy plane. Okay, if I have what kind of plane? So it means that I can draw the lines like this way. Hmm? All pointing in which direction? I cap direction. But this is present at some y is equal to 1. This is present at some y is equal to 2. So this is the representation of electric field varying as 6y I cap. Means this is a variable electric field in which as I increase the value of y, the strength of electric field increases. The strength of what increases? And they all are pointing in same direction, which is I cap. Are you able to get me or not? ठीक है? So look over here, how to solve then? My electric field, this means that electric field increases along y direction and pointing towards x axis. So here, if I write the formula of flux, so formula of flux is very good, 6y AB, but you can't take AB directly now, because what is happening for this level, the flux is 0. If I just consider nearer to x is equal to 0, y is equal to 0, electric field is 0 and flux is 0, isn't it? But at this top level, I have a different electric field. So the flux will be different, isn't it? So what I need to do, how I'll do, to do these kind of questions in which you have a variable electric field and in which you see that at each level I have a different electric field, अलग अलग electric field है. तो भाई फ्लक्स भी तो बढ़ेगा. अगर इलेक्ट्रिक फील्ड बढ़ रहा है तो इलेक्ट्रिक फील्ड लाइंस भी बढ़ेंगी, है कि नहीं. तो हर पॉइंट पे अलग अलग फ्लक्स आएगा. तो व्हाट आई नीड टू डू, आई नीड टू कंसिडर फर्स्ट a very small element. Okay, this small element will have once again length a, but this height will be just a small height dy because it is present in long x axis and it is present at a length y. Are you able to get me or not? So then area of that small means area vector dA vector will be what? It is just breadth into height a into dy, and normal will be once again along x axis, so a into dy n cap I cap. So the flux is simple, integral a vector dot dA vector. So that's why I have taken the variable cases. There are many variables happening over here, and for each kind of a variable another formula is getting applied over here. So you have to always look into the situation what is happening. Are you able to get me or not? You have to what? Look into the situation, otherwise you will always do the mistake. ठीक है. Okay, so it can be written as integral E dot dA is what? E vector is given 6y I cap dot A dy I cap. Why dot? So it is 6. 6a is common because it is constant, y dy, and y varies from 0 to b. Are you able to get me? So the answer is, this implies the answer will be 6a. This integration will be y square by 2. So 6ab square by 2, which is equal to 3ab square. Got it? Is that clear or not? There is nothing called as mainly. Let me make you understand what has happened actually. Okay, try to see. This is my area, and some amount of electric field line are emerging out of it. Take. Let me just draw like this way. And some amount of electric field lines are emerging. The point is, when I have non-uniform electric field lines, I have to be always cautious. The point is, if this electric field line is uniform, then I can just take electric field line into dot area vector and I'll get the answer, and I'm fine with that. But when जब मेरा electric field line constant नहीं है, when my electric field line is not constant, it's varying, means what is happening along this line it is increasing, or along this line it is increasing, or what so hell is possible over there. Are you able to get me or not? Okay, then what will happen? See, the normal is along the same direction. ठीक है. So then what will happen? What you need to do? You need to consider an element in this for which you will find the, like, let's suppose here I can say that this has some length dy. Basically it is in y direction, and this length was a and this length was b. Right or not? So then what you will do? You will find with respect to dy your particular electric field, and then since this E is varying with respect to y, I need to use the theorem that flux is equal to integral E dA. Okay, are you able to get me or not? But see that here this electric field is varying on that axis. मतलब समझ जरा अच्छे से समझ कि पॉइंट है कि इलेक्ट्रिक फील्ड लाइन दो तरह से वैरी कर सकता है, not only in one way. The point is simple that these electric field lines can vary in two ways. Okay, one along the horizontal and one along the, means these electric field lines can vary in two ways or not. See, here I represented you the electric field line varying along the direction of perpendicular to the direction of normal, isn't it? Means these electric field lines were increasing or decreasing in this direction. है कि नहीं? ठीक है, मतलब इलेक्ट्रिक फील्ड लाइन, एक मिनट मेरे को लिख लेता है, दिस इज इलेक्ट्रिक फील्ड लाइंस ई varying upwards or downwards. E can also vary along this direction, that here, let's suppose at this point, for this level, the electric field line is something else. So I write 2 points I'm mentioning. Okay. Let's suppose here electric field was 1 Newton per coulomb, and here it is 5 Newton per coulomb. And here it is varying like 1 Newton per coulomb, 2 Newton per coulomb. Here it is 3 Newton per coulomb, here it is 4, here it is 5. It's varying vertically and one thing can vary horizontally, isn't it? कुछ तो बोल हाँ या ना? तो ध्यान से सोच, जरा ध्यान से सोच, अगर तूने कुछ एरिया वगैरह लिया है यहाँ पे, एक एरिया यहाँ पे मान ले और एक एरिया यहाँ पे बना, दोनों रेक्टेंगल के एरिया क्या है? सेम। दोनों रेक्टेंगल के एरिया मान ले, दिस वन आल्सो इज 5 meter square and this one is also 5 meter square. But at these 2 points, all see, for both of them the normal is in the same direction, isn't it? So electric flux is going to be positive because electric field line is present along that side. But here electric field is different. It's varying along the horizontal line. So what will happen? Here the flux will be different and here the flux will be different. So here it will be 5 into 5 which is 25. Here it is 5 into 1 which is 5. तो बेटा अभी तेरे को वही बताया ना, दो तरह का वेरिएशन है. वन वेरिंग अलोंग एक्स एक्सिस, डोंट गो ऑन दिस डायरेक्शंस, go on the variation. First go on the, see, I cap j cap will tell you that what will be the varying electric field, void or not, and sorry, what will be the direction of electric field, while these things will tell you in which direction they are varying. Okay, so if electric field, remember that if the direction of electric field matches with the direction of n cap and the electric field varies perpendicularly to the normal, then you have to take the non-uniform case. And if the electric field varies along the direction of normal, then I have to just see the value of variable. Like let's suppose here it will be given as, सिंपल भाषा में बता रहा हूँ कि यहाँ पर ऐसे कुछ लिखा होगा, इलेक्ट्रिक फील्ड इज इक्वल टू, ये क्या है, एक्स एक्सिस पर जा रहा है तो 2x प्लस जो 5 वो लिखा हुआ है ना, वही है कि x की वैल्यू 0 पे 1 न्यूटन मान ले और x की वैल्यू ऐसा लिख दिया होगा कि x इज इक्वल टू 0 पर 1 कूलम है या ऐसा कुछ लिखा होगा. ओके, so what I need to do, I need to replace these variables. This means that if it is here 1, here it is 5, then means after changing the x, e is changing or not. So if I write electric flux over there, then that flux will not need integration. That flux will just require the replacement of value of x, void or not. So here, in these kind of cases, along the direction of normal, along the normal direction, then use the replaced value of x to find electric field and then flux. ठीक है, just replace the value of x, just like I replaced. I was saying that this area is present at which coordinate? 0 comma 0 comma 0. So this area will be also present on the x axis at some coordinate or not, and this will be also present at some x axis, got it or not? So find that coordinate, it will be shown to you, and then replace that coordinate value in the equation of E to get the particular electric field for those kind of electric field which varies horizontally along the direction of normal. Are you able to get me or not? Is that clear? तो दो तरह के वेरिएशन है अपन के पास, है ना, एक है हॉरिजॉन्टल लेवल का, एक है वर्टिकल लेवल का। अगर वर्टिकल लेवल का है तो तुम्हें क्या लेना पड़ेगा? एलिमेंट मानना पड़ेगा, क्योंकि यहाँ पे हर पॉइंट पे अलग अलग इलेक्ट्रिक फील्ड है, हर पॉइंट पे अलग अलग फ्लक्स है ना, और उन सारे फ्लक्स को ऐड करना पड़ेगा, तब जाके इस एरिया का टोटल फ्लक्स निकलेगा, है ना। तो हम इसलिए इंटीग्रेट कर रहे हैं। यहाँ पे ऐसा सीन नहीं है, यहाँ पे क्या है, हर कोऑर्डिनेट पे इलेक्ट्रिक फील्ड की अलग अलग वैल्यू है, लेकिन एरिया तो कांस्टेंट है ना। ऐसा थोड़ी ना है कि ऐसा थोड़ी ना कि यहाँ पे फ्लक्स अलग है, यहाँ पे फ्लक्स अलग है, ऐसा सीन नहीं है। इस एरिया के अंदर से फ्लक्स सेम है, बट इलेक्ट्रिक फील्ड की वैल्यू चेंज है। आर यू एबल टू गेट मी और नॉट? सो व्हाट आई विल डू, value of whatever electric field is present for that coordinate of area, and then you just find the flux. Are you able to get me? ठीक है, दैट कोऑर्डिनेट ऑफ एरिया मतलब इस एरिया का कोऑर्डिनेट को देखना। जैसे मान लो अगर मैंने इलेक्ट्रिक फील्ड इस तरह से लिखा है, इट इज रिटन एज, ये हटा दो, ये वैल्यू हटा दो, ठीक, एरिया बस पता है। एन इलेक्ट्रिक फील्ड इज गिवन एज 2x² प्लस 3 i कैप, है ना, and this is the coordinate 0 means this origin, this point has coordinate, like let's suppose 1 comma 0 comma 2, है ना, इसका कोऑर्डिनेट है 1 comma सॉरी 2 comma 0 comma 3 2 सॉरी, ठीक है। तो लुक ओवर देयर, एरिया पैरेलल है, बट कहाँ पे चेंज हो रहा है? एक्स एक्सिस में चेंज हो रहा है कि नहीं? ठीक, so the electric field over here, you see the x axis, what is that? 1. So just replace over there as 1 and you will get the electric field over here or not, and you get the electric field over here, then find the flux. Is that clear? So there are always two kinds of variation of electric field. Whenever it will come, be cautious of these kind of electric fields. In which direction it is given, it is very very necessary to understand, otherwise you will get definitely a negative marks. Now looking at the point, fourth question, that the electric field was varying like 3x square plus 2y I cap. Now here there are two variables, means it is saying that electric field is varying horizontally also, vertically also. So first thing, I have to find the electric field at the point of coordinate of area or not. Got it? Now you do not think that you will replace y as 0. Why? So बहुत लोग क्या सोचेंगे कि सर अगर दोनों तरफ जा रहा है और एरिया दिया हुआ है, तो हम x को भी रिप्लेस कर दिए, x का कोऑर्डिनेट, और if I know the coordinate then I'll replace y also and I'll get the answer. But that is incorrect. Why? Because along y direction I'm adding and along x direction I'm substituting. Are you able to get me? So this electric field must vary, as since this area is present at coordinate, like this plane is present on that field line, on that axis where x is present at 0 comma 0, isn't it? So this electric field will be at x is equal to 0, which is 3 to the 6. This varies like 6y I. Are you able to get me or not? Is that clear? if this area would have been drawn over here, अगर यही चीज यही plane, it should have been drawn somewhere over here, ठीक, then I would have replaced the different coordinate of x on this equation, right or not? But y value variation will be definitely find out through integration, because that is varying in a different way. Different way in the sense कि ऊपर की तरफ बढ़ते जा रहा है ना, वो कांस्टेंट थोड़ी ना है, तो उसको वो टोटल सम करना पड़ेगा, ठीक है? First you have to see in which direction the normal is there. First, you have to see in which the direction normal is there. Perpendicular to the direction of normal, I have to do the integration. Along the direction of normal, I have to do the substitution. Are you able to get me? Let's suppose I'll take another example. तुम तो भाई मार डालोगे मेरे को. I think these are not done in school or what? इसलिए that's why it becomes hard for us good kind of faculties to handle such a depth concept. बिकॉज मतलब जो पता है पर्सन लोग पढ़ाते नहीं है यार, इसीलिए दैट्स व्हाई आई फील बैड ऑफ सम इंस्टीट्यूट इन इवन इन इंडिया. पीपल डू लाइक दैट ऑन, लाइक दे विल नॉट टीच दिस काइंड ऑफ गुड कॉन्सेप्ट्स, व्हाट आर which are going to usually come in exam. Now you see that this is x, this is y, this is z. For this axis, here you can see this is my plane. In which plane? Xy or xz or yz? Xz plane, isn't it? Normal will be positive normal. Will be in which direction? Towards the y axis. Draw it, no problem. Just say it frankly. Towards the y axis, isn't it? Is that clear? Now, I gave you the electric field as uh, yes, as same question, 3x square plus 2 y j cap, but this time, heard or not? Why j cap? Because I need to put it along normal, otherwise it will be 0. I dot k is, because here it is j cap. Normal is along which cap? J cap. Yeah. If I take I cap area, electric field, then it is 0. Z cap, 0. ठीक. तो ये सब ध्यान में रखना है. Now you look over here. Once again, now you can see over here that this electric field is there. Now if I draw the electric field, imagine it. Means you do not have to write it. You have to imagine it. So if I draw the electric field, this is like this way, isn't it? Now, yeah. So point is simple. Then you identify the variable. E is along n cap. Then along which variable it is present? Y. So I have to substitute the value of y. E is perpendicular means E is perpendicular. The change in E is perpendicular along which axis? Means you look over here. If it is varying, if see, okay, let me write the steps. So first thing, E varying along normal. So substitute the value of variable. Substitute the value of variable. Got it? Second case, E varying perpendicular to normal. अब एक ही इलेक्ट्रिक फील्ड थोड़ी ना होगा, ऐसे हजारों होंगे ना. सो ई वायरिंग perpendicular to normal, follow integral method. So look over here, simple सी बात है. What is the coordinate? Like what is the coordinate of this plane? 0, comma 0, comma 0. This is lying in y plane. So this will all have some value of x, comma 0, comma z. This one will have also x, comma 0, comma some z. Right or not? Are you able to get me? So this is lying, this plane is lying at y value 0. If I just move this plane up, got it? If I just move this plane up a little bit, okay, then this plane will have some coordinate y. I agree. So this will have, let's suppose 0, comma 2, comma 0. So you have to see this value only, that this plane is lying on that axis, means along the direction of normal. First identify on which axis it is. Okay. So this along the direction of normal, it is y axis. Go ahead or not? Then start replacing the value of plane on the y axis with the particular electric field variable. Go ahead or not? तो जैसे इलेक्ट्रिक फील्ड दिया हुआ है यहाँ पे, तो ये प्लेन का हमारा निकालना है. मान लो हमको फ्लक्स निकालना है एबीसीडी के थ्रू. तो फ्लक्स थ्रू एबीसीडी, फर्स्ट थिंग आई विल रिप्लेस इज ई वैल्यू. ठीक, तो फर्स्ट आई नीड टू फाइंड ई थ्रू एबीसीडी. राइट और so E through ABCD along the direction of normal I have to substitute. So E along ABCD में y की वैल्यू क्या है 0, तो पुट कर दो. So it will be 3x square plus 2 into 0 j cap. So this electric field is how much? 0, which means flux is how much? 0. Okay, because it is varying like this way. Okay. Next thing, if I want to find similar case E of ABCD for y is equal to, let's suppose 2. So what it will be? 2 into 3x square plus 2 j cap. Are you able to get me or not? So I got a value of E or not. Now this electric field is varying for this particular plane. इसका मतलब क्या हुआ कि इस plane के लिए जो electric field है अब x axis की तरफ vary कर रही है साथ में. Are you able to get me or not? So then I need to consider a small element, because for a small value of x, for each value of x I have a different electric field. ठीक है? So I need to consider what? Variable dx, and then I need to find the flux. So flux इसमें क्या होगा? Total flux will be integral E j cap dot j cap to 1 हो जाएगा 2 3x square plus 2 into j cap. Then you have to see till which value of x it is going. Are you able to get me? So if it goes till value of 4 comma 2 comma 0, because it is in xy plane, so the equation will, this value will be integrated till, you see that here x is 0 and here it is 2 4, so it will be integrated from 0 to 4, and that's my flux. Take, so look over here. So this is my flux. See, this is the flux at ABCD when y was equal to 0 and it is used to come as 0. This is my flux at ABCD when y is equal to 2. And if x would have not been given, I would directly just have replaced the value of y and I would have got the answer easily. ठीक, okay, ठीक है. So you try this question. ठीक, last वाला part. and देन वी विल मूव अहेड, ठीक है ना। चलो तो आज इतना ही दूर रखते हैं बिकॉज माई माउथ हैज स्टार्टेड पेनिंग। ओके मीन्स